Hello and welcome. In this lab, I'll demonstrate how to create a GRE VPN tunnel between two networks and configure traffic to pass through the VPN tunnel. To keep this video short, I've pre-configured some of the settings, such as assigning IP addresses to all the interfaces on the routers and the computers. And the next step will be to configure the tunnel interfaces on both of the routers and then create a static route on the router to pass traffic through the VPN tunnel. I've also added all the commands that will be used. So at this point you can take a moment to pause the lab, pause the video, and make a note of all the settings or configurations that you see below the topology. So the steps that needs to be taken when configuring the VPN tunnel is first to create the tunnel interface. Then we assign an IP address, and what's very important is that both of the interfaces must be in the same network. So the network that I'll use is a /30. Then we'll set the tunnel mode to accept GRE IP traffic, and we'll define the source, and then we'll define the destination. So that will complete the configuration of the tunnel interface. And the last configuration is to create a static route on both of the routers to pass traffic through the tunnel for different networks. Without a VPN tunnel, traffic will normally pass from the computers on the local network to the gateway. Let's look at VLAN 10. If VLAN 10 computers wants to send traffic across the network into the different network, which is VLAN 20, they will first send traffic up to their gateway, which is 192.168.10.1, and the next hop router or the next hop IP address will be 193.1.1.6. Let's go ahead and start with the configurations on the router for VLAN 10, and that is router 1. So the first thing is to create this VPN tunnel and configure it. So the command to create the tunnel is interface tunnel 0, and here we can look at the options of what number that can be used. So there's a wide range of number that can be used for the tunnel, and I'll just use the first number available, which is tunnel 0, and I'll keep this consistent between the two routers. Next, I'll assign an IP address. And the address that I'll use for this configuration is 10.10.10, and I'll assign it 10.10.10.1 with a subnet mask of a /30. Next, I'll set the tunnel mode to GRE, generic routing encapsulation, and here I only have one option, which is IP. So I'm sending IP traffic over this tunnel. Now I don't need to set this tunnel to up or down, because it's once the tunnel is created, it's automatically up, because this is a virtual interface, and whenever you create a virtual interface, it is always up. Next, I'll have to define the tunnel source. And the tunnel source will actually be, I'll have to define an interface to specify where the traffic is coming from. So in this case, I'll specify gigabit 00. So any traffic that is coming from coming from gigabit 00 will be that source. So what options I have here is I have to select only an interface, and I can, in this case, it's gigabit, and it's 0/0. That's the interface that is connecting to the router on the other network. Then I'll have to define a tunnel destination. And the tunnel destination will be the next hop IP address of the neighboring router, which is 193.116. So that's my tunnel destination. Okay, so I'll go on the other end, on the other router, and make similar configurations. So interface tunnel 0. Give it an IP address, and this IP address must be in the same network as the router on the at VLAN 10. So we'll make this 2. That's the only IP address I can use, because the previous IP address was 1 that was used. The next address available is .2. Same subnet mask. And now I'll define the tunnel mode as GRE IP, and the tunnel source will be gigabit 00, because gigabit 00 is the exit interface for this router. And then I'll define the tunnel destination. So the tunnel destination will be the next hop IP address of the neighboring router. In this case is 193.1.1.1. Okay, so let's have a look and see if we have created the interfaces, if the tunnel interface is there. So we can just use a command of do show IP interface brief, and we can have a look at our tunnel here. It's tunnel 0. It's got an IP address, and it is up. The state of the tunnel is up, and we can run the same command here just to verify. Can't type today. So it's show IP interface brief, and here we have our tunnel 0, and we verified that the IP address is correct and the tunnel is up. So the next thing is I want to go ahead and test a ping from my router in VLAN 10 to the tunnel interface that I created on the router connected to VLAN 20. So ping 10.10.10.2, and there you get, I'm getting a reply. So now my tunnel is up. I've configured it with all the proper configurations. So the next thing is now is to create a static route on the routers, on both of the routers, so that we're on VLAN 10, we're gonna create a static route to pass all traffic for network 192.168.10.0 to 192.168.20.0. We're gonna create the tunnel so that traffic will pass through the tunnel that we have just created. Now, before creating the static route, I just want to go and have a look at the routing table on router 0, or the router that is connected to VLAN 10, and here you can see that there is no route for network 192.168.20.0. You can pause the video at this stage and have a look at the routing table, and then you will see no route exists to reach the network of 192.168.20.0. I can go and run the same command on the router that's connected to VLAN 20, and here you will see that similarly I have no route that exists for 168.10.0 on this router. So now I have to go ahead and create the static route. Okay, so to identify these routers, to show which VLAN they belong to, I've gone ahead and changed the host name of the router. So the router on the right, I renamed it to VLAN 20 router, and the router, the router on the right that's connected to VLAN 20, I've renamed that to VLAN 20 router, and the one on the left that connects to VLAN 10, I've renamed that to VLAN 10 router. So now I have to go ahead in both of the routers and create a static route so that traffic will pass over the VPN tunnel. So to save some time, I've already done the command. I'm just gonna paste it in here, and so this command is saying IP route. That's the command to create a static route. So this is on the VLAN 20 router. So in order to reach the network of 192.168.10.0, I'm saying IP route 192.168.10.0, that's the network, and this is the subnet mask that matches that network. I want to send that traffic to this IP address of 10.10.10.1, and this is the tunnel interface address that I've created on the VLAN 10 router. So now I'm going to hit enter, and on this VLAN 10 router, I'll create a similar command, but now I'll change this tunnel interface, the exit interface to .2, because this now is the IP address of the tunnel that I've created on the VLAN 20 router, and it's not network 10 I want to reach on here, it's network 20 I want to reach in here. So then let's go and examine. Now that I've created the routes, the static routes in both of the routers, I'll go ahead and check the IP routing table to see if both routers now have a connection or routes to the other network. Okay, now I'm looking at the routing table again, and here you can see now a static route has been added. I'm looking at the router for VLAN 10, and now here is a route in the routing table, and it's a static route. So for network 192.168.20.0, I want to send that via the tunnel interface, or the tunnel IP address, which is 10.10.10.2, and this is the tunnel address of the neighboring router. If I go over to the neighboring router, I'll see a similar static route here. So in order to reach network 192.168.10.0, I'll send that on my tunnel interface of 10.10.10.1, which is the tunnel interface address on the router connecting to VLAN 10. Now for the testing phase, I'm going to go ahead on one of the computer and use tracert. I'll go to PC0, and I'll make a connection now to PC1, and I'll trace the route that packets will take from source to destination. So I'm on router PC0 on VLAN 10, and I'll go ahead and use the tracert command to trace packets between VLAN 10 network and VLAN 20 network. So the command to use is tracert, and I'm gonna trace the route to IP address 192.168.20.10, which is PC1 on VLAN 20 network. Okay, so this returns the path that the traffic will take. So the first IP address that traffic sent to PC0 on VLAN 10 will send the packets to its local gateway, and then the next hop IP address is 10.10.10.2, which is actually the IP address of the tunnel on the next hop router, or the router connecting to VLAN 20, and then the final destination is the device that I'm pinging, which is 192.168.20.10. So this second hop tells me that the traffic is actually passing through the tunnel and not going directly to IP address 193.116, which is the public IP address configured on the physical interface of the next hop address. So this brings me to the end of the lab. If you like this lab, please subscribe to my channel and give it a thumbs up. Thanks for watching.